Hello everyone. In this video, we are going to see some grade 12 national exam questions of the previous years, particularly 2020. Let us see some questions and then we will proceed with additional video. Let us see some questions. The first one, f of x is equal to ln of to the power of tan x. There are three functions composed each other here. There is ln and to the power of that's exponential, and finally the tan, which is trigonometric. So we are asked to find the derivative of this function at 0. So first we have to derive the function. The derivative of this, the outer function, we have to apply chain rule. The derivative of ln, first let's remember, ln x derivative, it is 1 over x. And a the power of x, any exponential function derivative is just x, the exponential function as it is times ln of a. And tan x derivative, if it is a tan derivative, it will be sec square x. Remember this. Therefore, the ln derivative will be 1 over the whole everything that is to the power of tan x, the outer derivative. And then the to the power of something derivative will be to the power of as it is, because here we said a the power of x as it is times ln of the number. So that ln of 2 times again the tan x derivative. We have to proceed like step by step. We will start from the outer, the ln, and then we go to the exponential, then finally the trigonometric function. That is tan x derivative will be sec square x. Then at this point we can cancel to the power of tan x to the power of tan x. So what left, f derivative of x will be sec square x times ln 2. Then we let us substitute 0 now. F derivative at 0 will be sec square of at 0 times ln 2. But sec square 0 is just 1. So it will be 1 times ln 2 will be ln 2. How comes? Cosine 0 is equal to 1. And sec means 1 over cos. So 1 over cos 0 means it is just 1 over 1, which is 1. So this means when you square it, doesn't matter. So that the answer is going to be ln 2. That is the first question and its answer. Let us continue to the next one. Okay, when you come to the second question again here, it is function given to you. It says f of x is equal to ax minus b, and then f inverse of x plus 1 given. So first we have to find the function inverse. So f of x means, it's y is equal to ax minus b. So to find the inverse, in place of y write x is equal to ay minus b. In place of x write y. And then solve for y, make the y alone, that means. Then bring the b to the left side. It will be x plus b is equal to ay. Then divide both sides by a. Then the y become x plus b the whole over a. This is the same as f inverse of x. What do you do? First of all, f of x means y. Then in place of y write x, and in place of x write y. Then solve for y. Make y the subject. That means that is the inverse function. Therefore, we have f inverse now. F inverse of x is the same as x plus b the whole over a. But what's given f inverse at x plus 1? So when we say f inverse at x plus 1 mean it is the same as, we'll substitute x plus 1 in place of x here. So it will be x plus 1 plus b the whole over a. This one we can write it as, but this value is given to you already. F inverse at x plus 1, which is equal to 1 over 2x plus 2. Let's write it again. This is the same as 1 over 2x plus 2 given. But this one we can write it as, because the a is the denominator for each of them, but the variable is the x only. The other variables are constant. We need to find them. So 1 over ax, okay, we give the a for x also. X over a is the same as 1 over ax plus b plus 1 over a. This is equal to 1 over 2x plus 2. Why I write like this? Because the coefficient of x to the left side, that is 1 over a, is equal to the coefficient of x to the right side. So we can equalize. 1 over a is equal to 1 over 2 means by crisscross, a value will be 2. Done. Then again, the constant term to the left side is equal to the constant from the right. That is b plus 1 the whole over a is equal to 2. Then in place of a, substitute 2. And when you solve, the b value will be 3. So this is the answer for the second question. Okay, when we proceed to the next question, this is a matrix. It says 2 times the inverse of the given 2 by 2 matrix, this inverse, okay, is equal to the other 2 by 2 matrix. First, we have to find the inverse of this matrix. But remember, in case of 2 by 2 matrix, if we have A, B, C, D, 2 by 2 matrix, to find the inverse, first of all, 1 over of the determinant of it. The determinant, you know, by crisscross multiplication. So the determinant of the given matrix A, then multiplied with 1 over the determinant of it, multiplied with the adjoint of it. Like how to find the adjoint, exchange the main diagonal place. D will be here and the A will be here. And the other diagonal, just negate it, negative B and negative A. That's the way how to find the 2 by 2 matrix inverse. So when you find the inverse of this matrix, what to do first? The determinant. The determinant is 2x times negative 3, which will be 1 over of negative 3x minus, you know, determinant means first multiply the main diagonal, then minus negative 5 times x is negative 5x, which will be plus 5x. This is the determinant, the denominator. Then the adjoint of it will be, we will exchange the place of the main diagonal. That means negative 3 will be here and 2x to down. And the x will be negative, negative x, and the other diagonal I'm negating. So this is going to be 5. Therefore, this will be 1 over negative 6x plus 5x is negative 1 over x, you know. Negative 1 over x, 3, negative x, then 5 and 2x. Therefore, let's complete it, multiply. It's going to be negative 3 over x, and the other one will be just 1. And then negative 1 over 5, negative 1 over x times will be negative 5 over x. And again, it's going to be negative 2, the last one. Now we will equalize. This has to be multiplied by 2, the whole. 2 times of this inverse means negative 3 over x, then there is 1, and negative 5 over 2 x here, and then is negative 2 here. This is equal to what? We will multiply. When you multiply negative 6 over x, and then 2 here, negative 10 over x, and again negative 4 here. This is equal to given to us. The other matrix is 3, 2, and negative 5, negative 4. Okay. Now let us equalize the first entry with the first entry. Then we'll get the x value here. Negative 6 over x is equal to 3 means the x value by crisscross multiplication you will get it 2. That is what this is a question we are asked. If you equalize the second entry here with the second one, you will get the same result. But the rest, check it. Look, 2 here, 2 here. Correct. Negative 4 here, negative 4 here. So our process was perfect. This is the way how you can do. First, find the inverse and then multiply by 2, then equalize with the other. But how to find the inverse of 2 by 2 matrix? Like I told you, first find the determinant of it. How do I find? Just crisscross. 2x times negative 3, negative 6x, then minus negative 5 times x will be plus 5x. So that's the way how to do. That is question number 3. When we proceed to the next question, question number 4, we need to find the area of a region bounded by two functions are there. Y is equal to 1 and y is equal to e the power of 2x between the 0 and 2. So that the area will be the integral from 0 to 2. We need to take the difference between the two functions, e the power of 2x minus 1 dx. This will be, we can separately integrate. The integral of e the power of 2x is just e the power of 2x, but over 2 will be there, minus the integral of 1 is just x. From what to what? From 0 to 2. Each of them will be evaluated from 0 to 2. Then this is going to be 1 over 2 keep outside and substitute 0 in place of, substitute 4 for 2 for first here. When you substitute 2 here in place of x here, it's going to be 4. So e the power of 4 minus, again substitute 0, which will be 1. Again minus here, and in bracket for x also substitute 2 and 0. So 2 minus 0. This will be e the power of 4 over 2 minus, I'm multiplying, I'm distributing, 1 over 2 minus just 2. So this will be e the power of 4 over 2 as it is, will continue, minus when you subtract this one, it's going to be negative 5 over 4. Negative 5 over 2. You can check it. This will be the result for the fourth question. Okay, the last question for today, it's going to be integration. Let us see it. What does he say? What is the value of the integral? Okay, that means the integral, we will multiply. The 4 will multiply each of them. It will be 4x ln x plus 4x again will multiply 1 over x square, then dx. This will be Okay, let's continue down. This is going to be 4 will be constant and x ln x will left here, plus here the x will cancel, 1x just left, so for the integral 1 over x dx. Here also we do have dx. What do we do? Let's write it, dx plus will be there. Yeah, since it is plus, we can give the integral for each of them. In case of plus, we can separate. But this derivative is very easy. It's going to be 4 ln x, because 1 over x, the integral is just ln x. We are done to this one. Left this part. This one we cannot integrate without applying by part rule. So when we apply by part, let's bring it here. It's x ln x dx. So we can take one of it as u, the other one as dv. So let's take this one as u, this one as dv. So u is equal to ln x means, du is equal to 1 over x. And dv is equal to x means v will be disintegrated, 1 over 2x squared. Then the rule says uv minus v du. So when you do that one, uv means we'll multiply the two together. That will be 1 over 2x squared ln x minus the integral v du. That means I will multiply the two. 1 over 2x times 1 over 2x squared. So when you multiply, it will be 1 over 2x squared ln x minus first of all, this one, it's not 1 over 2x, just 1 over x. The du is 1 over x. So when you multiply, this is a square, 1 over x squared. So we will cancel square by square. So what left? 1 over 2, keep it outside. 1 over 2 times the integral x dx. The integral of x, again, x squared over 2. So this is going to be 4. So it will be 1 over 2 x squared ln x minus 1 over 4 x squared. This is the whole mean the integral of what's left here. So we'll multiply by 4. 4 times 1 over 2x squared ln x minus 1 over 4x squared. Okay, we arrived here. So the 4 will multiply each of them. When you multiply, this is going to be 2x squared ln x minus just x squared plus 4 ln x. Then we can take out common here. Common is x squared. So what left in the bracket? 2 ln x minus 1 plus 4 ln x plus any constancy. This is the last answer which is written in the choice. So this is the answer. Anyways, the main thing, okay, first multiply the outer constant for each of them, and then the next step after multiply, like you can separate the integration for each, and then the second integral will be simply found, which is 4 ln x, because 1 over x integral is ln x. But the first integral here, we need to apply by part rule. Part rule also has to be recalled, and we did it in that manner. We need to take care when we are doing that one. It needs really great focus and concentration. And finally, we have to combine and try to simplify it. That's the way how to do. For today, these questions are enough. I'll proceed with the next video. Thank you for watching.